Alright, B affects our graph by shifting it to the left or right. So when we add in the coefficient B, now we're moving our graph left or right, which is going to affect our axis of symmetry and where our vertex point is. That's why your equation is negative B over 2A. Now, I told you before that there was another way to find the x-intercepts, and that's by solving the quadratic function, which we do by graphing, or we do by factoring. What you do is you set y equal to 0, and let's talk about y. If we're talking about an x-intercept, then the graph is always going to cross the x-axis when y is equal to 0. So you set up an equation for y equals 0. I'm going to focus more on factoring at another time, so we're going to skip right through this slide. The graphing method is much easier. You simply look at your graph and find where it crosses the x-axis. So this one looks like it crosses at about 0 and positive 2. So you could also plug it into your calculator and find the x-intercepts by tracing. If we look at these graphs, x squared minus 4, we see that our x-intercept for the first graph is negative 2 and positive 2. Now when we look at the second graph, we see that we've added b. So it is around negative 5 and positive 3. The graph is shifting because we've added a b term. If you look at this graph, this is what we would consider a maximum. See how the u is upside down? The axis of symmetry is a little over negative 2, so probably about negative 2.4, negative 2.5, and a little over 2. This is an example of when we don't have any solution. Look, our graph doesn't touch the x-axis at all. So this would be no x-intercepts. All right. It's also a maximum because it's an upside down u. All right, so we have some observations we need to address. Sometimes you're going to have two solutions. Sometimes you're only going to have one solution. Sometimes it's going to be hard to locate the solutions because we're just looking at the graphs, and we'll get into more details about factoring to find an exact solution. But sometimes there's no solution at all. There's two solutions when I have 2 points touching the x-axis, one solution when my vertex is on the x-axis, and no solution if the graph doesn't touch the x-axis at all.